Our main topic is avionics, and our speaker is Ratnadeep Patra, avionics member of a Phoenix Aero. Yeah, Ratnadeep, you can go on.
So thank you, Meg. So these are the uh, hello everyone. So thank you, and these are the session objectives. So firstly, we are going to understand various electronic components that are present in a drone. Then we'll look into what are microcontrollers and what are microprocessors. Then we'll understand the pin configuration of an Arduino, and then we'll look few sensors, few different types of sensors that are available in the market. So firstly, talking about electronic components in a drone. So here we are using the terminology that the drone is just a RC quadcopter. So all of these terminologies are according to that. So the first electronic component is a BLDC motor or brushless DC motor. So compared to the brushed DC motor, which you might have studied, it's working in plus one, plus two classes. BLDC motor is capable of producing quite a lot amount of RPMs. So we require this high RPMs because we need to rotate those propellers at very high speeds, such that it can lift such a heavy object like drone, which can weigh a lot more than 1 kg or 2 kg or around that. So we are, if we are just using 4 BLDC motors, so yeah, we require very high RPM speeds. And as these are brushless DC motors, so there are no brushes present in this. So there is also less wear and tear in these motors. So as there is very less wear and tear, so we can use these motors for longer duration of time. So due to these benefits, we use BLDC motors in our drones. And moreover, in RC airplanes also, we use BLDC motors only. Next, we have the ESC, electronic speed controller. So electronic speed controller is basically responsible for controlling the RPM of a BLDC motor. So it sends PWM signal, pulse width modulator signal, and this pulse width modulator signal are just rectangular signals in which the percentage of the time when the signal is high in one time period can be varied, as seen in this picture. So this percentage is what we call, this percentage of the time for the signal is high is what we call duty cycle. So as seen in this figure, uh, the first signal is on for 50% of the time and off for 50% of the time. So that's why we tell this signal is having a duty cycle of 50%. Similarly, about to similarly, the second signal is having 75% duty cycle and 25% duty cycle. It's just an example. So using these PWM signals, we are basically controlling the RPM of the BLDC motor. Then we have the power distribution board, PDB. So one of the major problems that we face while giving power supply to all of these components is that the BLDC motor is requiring higher voltage, around 9 volts or 11 volts, but our other components like the receiver, flight controller, ESCs, they require just 5 volts power supply. So due to this, we require a power distribution board. So a power distribution board directly takes voltages from the battery and it reduces its voltage values to 5 volts, so that this 5 volt supply can be provided to all other components, and simultaneously it connects the battery directly to the BLDC, so that constant supply of 9 volts or 11 volts can be supplied to the BLDC, which is requiring higher voltage. Next, as we are speaking about RC quadcopter, RC radio control, so we definitely need a receiver. So a receiver basically receives radio signals that are transmitted by a transmitter by an operator on ground. So after receiving these signals, it sends messages to the processing unit, the brain of the drone, which is the flight controller, and further tasks are done by the flight controller. Next, we have the battery, the powerhouse. So we generally use LiPo battery, lithium ion polymer battery, and The reason for using this is that these lipo batteries are having higher energy density compared to its size and compared to its weight. So as we know that for any UAV, we need to reduce its weight as much as possible, because lower the weight, more using less lift force we can operate it. So as lipo battery is providing higher energy density compared to its weight, so we generally use lipo batteries. And moreover, the lipo battery is also providing higher mAh values. So due to high mAh value, so it can provide constant power supply for longer duration of time. So if it is providing constant power supply for longer duration of time, we can have uh, greater flight times. Next comes the flight controller, the brain of the drone. So a flight controller basically receives the signals from the receiver, and then depending on what the user wants the drone to perform, it sends signals to the ESCs, and the ESCs produces the PWM and controls the RPM of the BLDCs, and accordingly we can control the drone. So let's understand the working of this flight controller using a simple example. Let's say the user asks the drone to pitch. So what basically this flight controller will do is that it will decrease the uh, RPM of the front two BLDCs, and it will increase the RPM of the back two BLDCs. So, and keeping in mind that the drone does not start to yaw, so it is constantly increasing and decreasing the speeds of the RPM of the BLDCs. At the same time, it is also checking whether the drone does not start to yaw, and this checking mechanism is basically done by a sensor. So like flight controller has two units, the sensors and the processing unit. So the sensors is saying whether how much angle the drone has pitched, or how much angle the drone has roll, or how much angle it has yaw. So it is giving that input, giving that output, and then the processing unit is performing the other task. So while performing this pitch action, uh, the flight controller is constantly increasing and decreasing the speeds of BLDCs. It is at the same time, it is also checking the drone does not start to yaw, and at the same time it is also checking whether the drone has uh, achieved the pitch angle that the uh, user is asking. So it is checking all of these three things. This processing unit in the flight controller is checking all of these three things in a closed loop system with the processing unit and the sensors. So we are constantly speaking this processing unit, processing unit. So what exactly is this processing unit? So the processing unit is nothing but just a microcontroller or a microprocessor. So these are few images. So what do you think? Which one is a microcontroller and which one is a microprocessor? You can.
Third is microprocessor.
The first is a
First is
microcontroller,
Third is
microcontroller.
second is microprocessor.
The third is microprocessor.
Okay, and about first and second.
First microcontroller.
First is
That
microcontroller.
First is microcontroller.
First is microcontroller.
Okay, yeah, and about second.
Microprocessor.
Okay,
It is IC circuit.
okay. So yeah, so the first one is definitely a microcontroller. It is Arduino Uno, and the third one is definitely a microprocessor. The second one is also a microcontroller. It is Atmega 328P. It is a microcontroller. So let's dive in a little bit inside in a microcontroller. Let's see what are the blocks it has. So let's look at different blocks of a microcontroller. So the first one is the CPU. So the CPU contains two units, the ALU unit and the control unit. So the ALU means arithmetic and logical unit. The arithmetic unit performs arithmetic operations such as addition, subtraction, modulos, and all of these operations are performed on binary numbers. And the logical unit performs logical operations like and, or, all these logical operations. and all of this all of these actions of the ALU are working on some certain instructions that it is receiving. So like if the instruction says to add the following binary numbers, so it will perform the addition operation. So in a similar way. And what basically this control unit does is that it systematically sends instructions and data to the ALU. So the ALU is performing all the processing and the control unit is controlling the ALU. Okay, so next is the memory block. So for like if a microcontroller has received some data or microcontroller has to output some data, or whether the program instructions that tells the microcontroller what all things has to be done, all of these things are stored in the memory. In fact, the temporary variables that are generated while performing some process, all of these things are stored in the memory. So the memory has two parts, RAM and ROM. So in a microcontroller, generally, RAM stores the program instructions, those instructions that tells the microcontroller what all things it has to perform on the data. And next is the RAM, and the RAM stores all the other stuff, maybe the data that the microcontroller receives or the data that microcontroller has to output, or those temporary variables that are generated. All of these things are stored in the RAM. This memory stores all of this data using an electronic component called registers. So what basically, like each register is capable of storing 1 bit of information. 1 bit means either 0 or 1 in binary. So 0 or 1, high or low. So it is capable of storing 1 bit of information, one register. And if we club together 8 registers, then we have 8-bit information. And 8-bit is nothing but just 1 byte. And generally, any microcontroller has memory space in ranges of around kilobytes. So next, coming to the input-output pins. So to interact with the external environment, microcontroller requires some input-output pins. So what basically this unit does is that it contains some special registers that keep a track of whether any data has been received or any data has been outputted. So how it can keep a track is that every time data has been inputted or outputted, it converts the value of the special registers from 0 to 1. So this way it keeps a track of everything, whether microcontroller has received or outputted some data. Okay, so next we have the interrupt. So interrupt gives us the flexibility to pause a current program. Like while pausing the current program, all of those program instructions and all those temporary variables and all of those things are still stored in the memory. It's just that the program is on hold. And while keeping the program on hold, it is performing some other task of immediate importance. So the program is on hold, then some other task of immediate importance is been processed in this microcontroller, and after performing the task, then the previous program just resumes. So this is just a flexibility that generally all microcontrollers provide. So next is the serial communication block. Now, what exactly is serial communication? Serial communication is a way in which the data is communicated, like either received or transmitted, using just a single wire. Unlike parallel communication, in which we are using a set of parallel wires for communicating for either sending or receiving data. In serial communication, we just use a single wire. There are some merits and demerits of serial communication. Is that like a serial communication in parallel communication is way lot faster than serial communication, but a serial communication takes less space compared to parallel communication. So depending on what we need, the microcontroller uses both serial communication and parallel communication. But for a microcontroller to communicate with other microcontrollers or other microprocessors or some other sensors, we generally use serial communication. Next is ADC, analog to digital converter. So what basically this ADC does is that it takes a continuous analog, uh, continuous range of analog signals, like maybe analog signal in a sense like a continuous range of voltage. So and it is taking those voltage and it is converting it to a binary, some digital value, like some example, binary value, binary number. So, for example, let's suppose we are having a 10-bit ADC and the input voltage for this ADC, it is taking input at a max of 5 volts only. So the input range is 0 volts to 5 volts. And as this is a 10-bit ADC, so it is outputting 10-bit binary number, and the range of any 10-bit binary number is from 0 to 1023. So what basically this ADC is doing is that it is mapping the input range from 0 volts to 5 volts, mapping this input range to the output range of 0 to 1023. So, the maximum input voltage that this ADC can take is 5 volts, and the maximum output it can give is 1023. So we can say like, okay, so the 5 volts is analogous to what? 1023. So for any other input voltage between 0 to 5 volts, so we can calculate its what will be the output for that voltage using some unitary method. So like if 5 volts is 1023, for example, if input voltage is 2.44 volts, so what will be the output? So using simple mathematics, we can calculate, okay, it will be 500. So this way ADC works. Okay, so next is the timer and counter block. So a timer basically is a block that creates a continuous clock signal pulse. So what exactly is a clock signal? So a clock signal is just a rectangular pulse of 50% duty cycle, and this rectangular pulse is having frequency of very high frequency. So what basically this clock signal is doing, it is that it is basically keeping every other blocks shown here, every other blocks present, it is keeping all of those blocks in sync. So that is the work of the clock signal. So, and one more thing, you can say that higher the clock frequency, higher this clock signal's frequency, more is the processing speed of this microcontroller. So a microcontroller generally have clock signals in the range of megahertz. So next, coming to the counters. The counter basically keeps a track of how many times a particular process has been executed. Let's say microcontroller is asked to perform a particular task 5 times. So every time the task has been performed, the counter value is incremented by 1. So this way it is keeping a track of how many times a particular task has been completed. Next, coming to the DAC, it is just a complete opposite of ADC. It is just converting digital signals to analog signals, and we can calculate what will be the output of DAC for any particular input using a similar way, using a unitary method in a similar way that we did in ADCs. So these are all of the major components that are present in every microcontroller. So, okay, so this was microcontroller and this was microprocessor. So what do you think are the basic difference between a microcontroller and microprocessor? You can speak up, you can unmute or write in chat box.
Sir, microprocessor are more complex than a microcontroller, and they are very less. They are more efficient and consumes very less energies to work.
Okay.
Sir, in microprocessor, we have a limited number of instructions which need to be means which needs to be followed, but in a micro processor, it is much more complex as compared to microcontroller.
Okay. Like, where do you think microprocessor is used and where microcontroller is used?
The microcontrollers might be used in small drones and sensors, and microprocessor are used for in the laptops and supercomputers,
Okay.
and spacecraft and stuff.
Okay. So yeah, you all are like partially correct, partially wrong. So okay, so let's clear this out. So like microprocessor, it basically does not have various options to interact with external environment. Like we saw, like the ADC or the DSE that are present in microcontrollers. Those elements are not present in a microprocessor. A microprocessor is just mainly the CPU. It is just a processing unit. It does not have various options to interact with external environment. So for those for so we have basically we just have to connect ADC element or DSCs to the microprocessor. We have to externally like connect those things. And as we are connecting these things externally, so it is like the whole system is like there are more electronic components present there, so the microprocessor is consuming more power compared to a microcontroller. But if we say about the clock frequency that we discussed earlier, so in a microcontroller, the clock frequency is only in the range of megahertz, but in a microprocessor, it is in the range of gigahertz. So we can obviously say that a microprocessor is having a way lot processing speed or way lot processing power compared to a microcontroller. So yeah, you as you mentioned that microcontrollers are used in drones and all those stuff, and microprocessors are used in our personal computers, PCs. Yeah, it is because the microprocessor is capable of higher processing power. So that processing power is required in our personal computers, but in like you may say in drones or some simple applications like in washing machines and those stuff, we are just required to perform some small operations. So that can all those operations can easily be performed using microcontroller. We do not need more processing power for that.
Sir,
But are microprocessors pre-coded and they are just ready to use, while the
uh,
microprocessors need to be assembled first and then compiling with the assignments?
Look, it like both of them can be programmed. Like it depends on what microcontroller and what microprocessor you are using. Both can be programmed, but it's just that the programming of a microprocessor is way lot complicated than in a microcontroller, because we have to externally connect these things and externally connect these other elements, and its circuit also becomes a little complex compared to a microcontroller, because microcontroller has all of these things built in, so it is easier, but it does not provide this processing power that microprocessor provides. So moving forward, so
Sir?
yeah.
sir, is there any particular merit of microcontroller over microprocessor?
Merit in a sense, like this provide like several other input output options are provided in a microcontroller that are built in, but in if you are programming a microprocessor, all those instructions are like you even have to write code for performing a simple ADC operations, but in microcontroller you can just directly use its built-in feature. So but so in that case, but microprocessor is having higher processing power, that's why it is just more used in PCs, but we will never say like you are using a microprocessor in washing machines or in drones or in these simple applications where processing power is not a big thing.
So can we
Okay, sir.
manipulate microprocessor to make it a microcontroller?
Yeah.
like a more efficient microcontroller.
Yeah. So like microprocessor is just the CPU part of, like you can say the microprocessor is majorly the CPU part of this microcontroller. So if we add all other blocks to the microprocessor, so yeah, we can use that. But and in like storage technologies, there are some PCB designs in which we are using like we are giving all those options that microcontroller has, and at a time we are also using a microprocessor. So we'll look that into detail in the next slides. Uh, okay, so we'll just take on all the questions at the last, or you can just write in the chat box. Let's continue the session first. So next, we are talking about Arduino. So this is one of the microcontroller, most popular in a sense. Like many of you have worked with Arduino, and specifically saying we are just talking about Arduino Uno. So let's look at various pin configurations that Arduino Uno provide. So on the left hand side, the last 6 pins are what we call analog pins. These are named from A0, A1 to till A5. And this basically takes analog input, and the built-in ADC in the Arduino converts these analog inputs to digital outputs. So like converts these analog inputs to binary numbers, and then the Arduino performs processing on those binary numbers. So Arduino basically has 8-bit ADCs, and the input range for this ADC is from 0 volts to operating voltage, and this operating voltage can be both 5 volts and 3.3 volts. We can also manually like what to say, change this input range using the air reference pin that we'll see later on in the slides. Okay, so moreover, apart from just being analog pins, the A4 and A5 pins can also be used for serial communication that we discussed earlier, for communicating with other microcontrollers, like Arduino is communicating with other Arduino, or communicating with other sensors. Those are stuff can be performed using the serial communication. So these 2 pins are ground pins. So this basically have 0 voltage, and like you might have seen, like for any circuit to work, we have to mention the ground, which point should be ground. So for that thing, we can use these ground pins. And then these 2 pins are 5 volts and 3.3 volts respectively. Like using these pins, we can set what operating voltage we want to work on. And this is the reset pin for resetting the whole Arduino. On the right hand side, firstly we are going to discuss the last 14 pins. So the pin 0, 1, 10, 11, 12 and 13. All of these pins can be used for serial communication. In a similar way that we see, A4 and A5 pins can be used for serial communication. So these pins can also be used for serial communication. Moreover, all of these 14 pins are what we call digital pins. So it can take input and output digital values. So these pins are capable of taking input and output of digital values. So as these pins can be used for both input and output, so while programming the Arduino, we basically have to mention that whether we are using these pins for input or we are using this for output. The analog pins that we saw earlier, those A0 to A5, those pins can also be used as digital pins. It's just that while programming, we just have to specify that we are using these pins for digital pins. So you can also use those pins as digital pins. Apart from being the digital pins, these following pins can also be used for outputting PWM signal. We saw now that PWM signal is responsible for controlling the RPM of any BLDC motor. So using these pins, we can basically control we can just directly attach the BLDC to Arduino using these pins, and we can control the speed of this BLDC motors. Above all these 14 pins, we have this ground pin, and above this we have the air reference pin. Air reference is just meaning analog reference. So using this analog reference pin, we can basically control the input range for this ADC. We mentioned earlier that we can also manually control the input range for ADCs while discussing those analog pins. So using this pin, air reference pin, we can control the input range. So we can also give a DC power supply using this DC power jack. And for programming the Arduino, we basically have to connect Arduino to our PC using this USB port. And this then we can write code on Arduino IDE and upload it on Arduino using this USB port. Apart from uploading the program, you can also use USB port for providing the power supply, DC power supply that it requires. Okay, so what do you think? Why Arduino is so popular? Like apart from other microcontrollers, many of you, as you have mentioned before the starting of the session, also that they have worked on Arduino and those stuff. Like, is it that the Arduino programming is easier than microcontroller, or what do you say? Anyone who has worked on Arduino? Like, what do you think? It is easier or what?
So pre-built functions are available in it.
Sir, it has pre-built functions, and also it has a much easier environment to code and test. Means for when we are using Arduino, it provides a much better interface as compared to many other microcontrollers.
Okay.
Sir, we can easily use it for our purpose. Means we do not need to code much. Basic codes are there in it.
Yeah. So while that is one point, that while writing code in the Arduino IDE, we have like a lot of predefined functions that we can use. Okay. Apart from that, is there any other benefit?
It can easily be connected with other computers and all.
Okay. Any other benefit?
So DC slot is also provided there.
Okay.
It do not need much hardware to connect with other things.
Yeah. So as you can directly see in this image also, so the main processing unit of this Arduino is just Atmega 328P. So it is the main microcontroller, main processing unit that is performing all of the tasks. But apart from that, the Arduino board is also consisting several other things like this DC power supply that you mentioned, or we can directly program using the USB, or there are some other integrated chips that are allowing us to, like, we can use this analog pins as also digital pins. So this flexibility is all provided using this PCB design, using these integrated circuits that are attached to it. So with using this, due to this flexibility, Arduino coding is way lot easier. And as you also mentioned that in Arduino IDE, we have so many predefined functions. So we does not have to write the code from scratch. While programming any other microcontroller, we need to know its architecture and we have to write the code from scratch. That is not the case with Arduino. Like here, I have just mentioned various pins of Arduino. In the next session, you are just there is a hands-on session in which you are going to learn the Arduino programming. So you will learn more about Arduino in that. So like you mentioned earlier, okay, so can we use microprocessor and attach various components and make it use as a microcontroller. So yes, you can, and this is what we call embedded computing board. Some of its examples are Raspberry Pi, Jetson Nano, Jetson Xavier. This Jetson Nano and Xavier are created by the NVIDIA company. So what is the benefit of using this embedded computing board is that it provides quite high processing power, as we are using microprocessor instead of microcontrollers. And its PCB design is such that it also provides various options for communicating with the external environment. And somewhere like in this Jetson Nano and Xavier, the processing power is way lot higher because it also provides GPU, so its processing is way lot higher. So these are also a common choice while writing any code, like if we are implementing some machine learning algorithm or we are performing some image processing. So for that stuff, these boards are a popular choice. So next, coming to sensors. So what do you think is a sensor is?
So one type of detector.
Okay, detecting what?
Signals.
Okay. Anyone else wants to add on?
Sir, it depends on
Sir,
programming.
sir, sir, a sensor is basically a device which gives us any output when there is any physical phenomenon occurred. Means any sudden physical phenomenon occurred, then a sensor gives a particular output. Now it depends upon the programming of the sensor what output it will give.
Yeah. So you are right. So like depending on the physical environment, it is a device that detects and responds to some type of input from the physical environment, and it is converting this input that it received from the physical environment to some output that can be processed by these processing units like the microcontrollers, the microprocessors, or this embedded computing board that we saw earlier. So it basically is converting the data from the physical environment, and it is processing in a form so that the processing unit can work on. So let's look into a few of the sensors that are available in the market. So firstly, we have the ultrasonic sensor. So an ultrasonic sensor is capable of detecting objects that are in front of it. So like if there is an object in front of the ultrasonic sensor, so it is able to detect that object. And not only that, it can also detect how far this object is from this sensor. So how exactly it works is that there are two blocks, the transmitter and the receiver, denoted as T and R in this diagram. So the transmitter sends ultrasonic sound, and when this ultrasonic sound receives, it reaches till the object, or it collides with the object, so this ultrasonic sound is reflected back, and this reflected signal is then received by the receiver end. So the ultrasonic sensor then detects the time delay between the transmission of the signal and the receiving of the signal. And using this time delay, we can easily detect how far an object is. So this is the basic concept of an ultrasonic sensor. The sensor shown here is the SCSR04 sensor, ultrasonic sensor, which basically contains 4 pins. One pin VCC, one that is the power supply 5 volts, and then one ground pin, and the 2 pins trigger and echo are for the trigger pin is transmission of ultrasonic sound, and the echo pin is for receiving the ultrasonic sound. So using these 4 pins, we can detect any obstacle that are present ahead of it, or we can also detect how far this obstacle is. So it is a common sensor while designing an obstacle avoidance system. Next is the IMU, or inertial measurement unit. While explaining the flight controller, I mentioned a sensor. So it is this sensor, the IMU sensor. So IMU basically contains two parts, the accelerometer and gyroscope. So the accelerometer basically detects linear acceleration, its value of linear acceleration along z-axis, y-axis and x-axis. So it is detecting linear acceleration. And the gyroscope, it basically detects angular velocity about x-axis, y-axis and z-axis. So this IMU can detect both linear acceleration and angular velocity. And moreover, like today's IMU also contain magnetometer. So using that magnetometer, so we can detect the magnitude of magnetic field and also the direction using this sensor. Next, we have the photoresistor. As one of your friend also mentioned that he has worked on this project. So this is the photoresistor. So these sensors are we basically use this sensor for detecting how much light intensity is falling at a particular area. So it is just a simple resistor, and the value of this value of its like the resistance value of this resistor changes on depending on how much light intensity is falling on it. So if more light is falling on it, so its resistance value will decrease, and vice versa. So using this sensor, we can easily determine how much how much light intensity is falling at a particular spot. You can directly see that if we give some voltage at one pin of this photoresistor, let's say 5 volts, and if we check the voltage on another pin, so it will be like, let's say it is having a value of 2.5 volts. So we can directly attach this pin to the ADC, the analog pins that we mentioned earlier in the Arduino, and using that we can detect, like, if we are getting 5 volts, it is complete darkness. If we are getting 0 volts, it is like direct light intensity. It's direct light is falling on it. So in a similar way, we can receive data. Next is the temperature and humidity sensor. So this basically detects the temperature and humidity of the surrounding. So the sensor shown here is the DHT11 sensor, and it is having 3 pins. One is the VCC 5 volt pin, other is the ground pin, that is the 0 volts, and the third pin is that is outputting the data. It is at the same it is outputting data of temperature and humidity in a form of serial communication. So this was the temperature and humidity sensor. It will just output 0 volts or 5 volts, that is the binary 0 and 1. So using that, we can either on an LED or off an LED. So in some way we can control all 64 LEDs using just 64 digital out pins. Like controlling in a sense, like let's say we number all of these 64 LEDs 1 to 64, and if we just say using these 16 pins, I just want to control I just want to turn on the LED number 5, 10, 15 and 50. So can we do that? So this is the question of the day, and thank you.